So the personality survey will be up through Monday or so. We're definitely shutting it down at some point. It's not up right now. I've activated 2 more Quest quizzes that will start at about noon today, and they go through next Saturday, so 8 days. What? Oh. Someone have a question about it? I regraded exam 2. I haven't posted anything on it, but I took into account challenges, and the mean has gone up 2 points. So that's kind of current stuff. To pick up where we left off last time, I'll give you some questions. So this is off a previous exam. Questions concern whether we're invoking a third variable. Not only is it reviewing last time, but I'm going to introduce a new point. So here's the problem. Societies with high per capita alcohol consumption have shorter lifespans than countries with low alcohol consumption. One causal model is that alcohol reduces lifespan. Which of the following models instead invokes a third variable to explain the cause of this correlation? In answering, recall that for models that invoke a third variable, reducing alcohol consumption of a society will not by itself increase lifespan. Let's start not with A, but with B. So you can still see the problem. I guess there's no way to do that. Okay. So focus on the one just above the blank paper. Causal model. The physical environments of societies with high alcohol consumption are stressful. Stress reduces lifespan and causes people to drink in excess. Does that invoke a third variable? And I'll activate this so you can look at up to 8 responses already. Okay, I would say so far so good. What's the third variable? Physical environments, stressful physical environments, yes. So that is the third variable. This one is actually going to be an excuse to introduce something that I didn't quite get to last time. So the model is drinking alcohol in excess leads to violent behavior. The alcohol-induced violent behavior is what lowers lifespan. Oh, I got to go clear this out. Don't enter it. So this is a problem on whether we invoke a third variable in a causal model to explain a correlation. And if you're not texting, you ought to be at least writing an answer, in your notes, so you have the mental experience of guessing or hopefully not guessing, but getting it wrong, right? Because if you just sit there and you don't do that, you can convince yourself of anything when the answer is revealed. Just like last hour. Good. So someone defend an answer. Yes. Okay. Someone defend the other answer.
Violent behavior doesn't influence alcoholism.
Ooh. I might get back to that. What? So someone defend an answer that we are, oh, sorry, maybe I said it wrong. Maybe defend an answer that we are invoking a third variable.
Well, you could say that there's something in between alcohol and then violent behavior that lowers inhibitions or something like that.
Well, we've introduced, so here's what's going on. X, which is, so we have X and Y. What are X and Y in this problem? What? Okay. What does this problem invoke in between these two? Violent behavior, that. So that's the model that's being done, right? In one sense, we do have a third variable. It's called violent behavior. But, okay, we don't want, it's not what I want to call a third variable. When I use the word third variable, I want it to be outside the context of the problem. Because almost any causal model will have many of these things in the middle. So what we want to focus on is what he said, is simply if you change X in the model, will you change Y? So with this particular model, if you change X, will you change Y? Yes, because the amount of alcohol affects that, right? High alcohol, high violent behavior, changes shorter lifespan, etc. So we would say in this case, and so this is actually, I'm introducing this, no third variable. Now, if the problem was written in a different way, such that violent behavior was outside there, that there's societies that drink a lot have violent behavior for, there's some other reason, and maybe violent behavior is causing people to drink and doing that, we would say in this case there is a third variable. Because it's outside the connection between X and Y. It's driving both X and Y in this problem, but the way it's worded here, X is driving violent behavior, is driving that. So here the answer is no third, but here there would be yes, a third. Yep.
So even though technically there is a third variable,
What?
third variable
When?
only refers to
Outside.
like a working variable.
A variable outside the direct connection between X and Y. And I could, if you want me to, I can word it nice and long to say a third variable outside the causation between X and Y. Or we can just understand that when we say a third variable, it means outside there, or equivalently it means that if I change X, I don't get a change in Y. So right now, the way I want to use third variable, it is synonymous with saying if I change x, I don't get a change in y. So if you don't like that, if you want me to word it differently, tell me. We could say an outside third variable if you prefer, or just understand it. But basically, throughout, if changing x leads to a change in y, for the model, we will be saying no third variable is invoked. However many intermediate steps there might be in there. Cool? Let's do two others. Societies vary in the physical activity, exercise levels of their populations. Those with lots of exercise do not have time to drink excessively. Those with little exercise have plenty of time to drink. High levels of exercise increase lifespan. Ooh, we got a tie last time. So, does this invoke a third variable? An outside third variable. Okay, most of you are on target with this one. What's the variable? Exercise is a variable. High is one state of the variable, low is a different. Last one, high levels of alcohol consumption in a society is increased social dysfunction. Social dysfunction reduces lifespan. Oh, don't text anything in yet till I clear it. Okay. So, not as strong as before. So someone describe, someone describe what's going on in this problem. What are we going to put where? And I know that's a very suggestive question to put to you. There are lots of opportunities for you to suggest things outside the context of what we're talking about.
Can't alcohol consumption be the third variable?
Alcohol consumption, I thought that was here.
Because it can influence both social dysfunction and lifespan.
So do you want to put So we've got this, we've got this. First of all, what's the third variable in the problem? You read it, what else is in there? Social dysfunction. The question is, where does social dysfunction go in this problem? Does it go here or here? Really? Oh. I would have said the way the wording is this. What? Okay. Alcohol consumption causes social dysfunction. Isn't that this? Well, I mean, in part, so he won't be the only one confused about this, but I'm trying to understand why you think it's written this way. Then social dysfunction reduces lifespan. So I think this arrow can't, so we agree this arrow applies, right? The question is, does this arrow apply if this was social dysfunction down here? Can you have this arrow or this arrow? And the problem clearly is this direction. So that's how I would dissect it. But that was a very useful discussion, right? So when you start going over these, and you're not going to do it this weekend because we don't have a test for another 10, 12 days, but when you look over these things, this is how you should start dissecting the problems. You should look at this and say, okay, what's going on? Write things out. I know that's easier said than done, but that's what I'd like you to do. No, because it wasn't that way, it was this way. And so by changing X, we would change Y. By changing alcohol consumption, we would reduce social dysfunction and hence increase lifespan. But yes, there is a separate issue that I do not know how to solve, which is you can understand all the material and the problem, but you got to figure out what the question is asking, and sometimes it's easy to flip them around. And I just don't know what to do about that. Oh, good.
If we're saying X leads to Y, like, couldn't someone make a case for saying social dysfunction reduces lifespan, and then social dysfunction is X, and then lifespan is Y?
Yes, but you've got the first one being alcohol,
I feel like if I saw this on a test, I don't know what I would be like, I feel like there's two separate.
There are two separate causal models, right? So alcohol consumption causes social dysfunction. And then social dysfunction reduces lifespan. These are both causal models, correct? That's where these arrows are coming from. So that's how I'm dissecting. Now, believe me, there are times when someone points out another way of looking at a problem, and I think, oh, for God's sake, why didn't I see that? So I'm not trying to argue with them. I'm just saying, to me, the problem clearly states we have two causal models, one here and one here.
That was my problem. Using the bottom of social dysfunction reduces lifespan, and alcohol would be considered the third variable. At the top it says
So we do have three variables, right? It's just social dysfunction doesn't lie outside of these in the problem. One's leading to this, this is leading to that. But, so we have what we can call an inside third variable, as opposed to an outside third variable that's causing both of them. So the other way to do it is to think of this as, how would this problem be worded? And it would be social dysfunction causes high levels of alcohol consumption and reduces lifespan. That's how that would be worded. So you'd again have two causal models, but this would be the driver of both. We were invoking this as an outside third variable.
So social dysfunction would have to cause increased alcohol?
Yes. And also cause lifespan reduction. Yes.
So if we see this on a test, it's pretty safe to set up a little diagram that you have.
Yep.
Before we even get to the causal model, you tell us what X and Y.
Yep. So X and Y are set up here, right? X and Y are set. So alcohol consumption, lifespan. They will be set in the introduction to the problem. Yes. Well, figuring out whether it fits this or this. Ah. Okay. This is about 10 times better discussion than we had last hour. No, it really is. I mean, it's great if you admit that I'm confused about it, or it's even better if you can find that I'm confused about something, right? I mean, that's really the goal, is to show that I don't know what I'm talking about. And I'm happy to admit I don't, but you guys don't realize that. But this is good. This was super. But we've run out of problems. So now I get to start lecture. But if we could do this every day, then it'd be great. And of course, what do we have? 15% attendance today. So very few of the class are benefiting. What I'm going to talk about today are more about hidden variables and controls and control groups. So I want to go back to our car color example and look at it a different way. Which is better? If you can't see it, or you can. I'm going to create a table. We have red cars and not red. And we have higher accident rate, low accident rate. And then we said, well, what could be going on here is that drivers of red cars could be riskier than drivers of not red cars. The types of cars that tend to be red could be not safe. Cars might be older if they're red, and so on. So this is the third hidden variable problem. And it's not that, right, that these variables exist. It's that they could be disproportionate or between red and not red, or unbalanced. So indicate here that these are variables that might be we'll say unbalanced between red and not red. So this is our third variable problem, right? It's just another way of looking at it, visualizing it. So what can we do about this, or do to correct the imbalance? And of course, it's a rhetorical question, right? We balance it. How do we balance it? And by balancing, we mean we make them the same for red and not red. So when we're interested in the effect of something like car color or fluoride in the water or something, we will refer to the individuals with that attribute as our treatment group. So they have the characteristic of interest. And our control group will be the individuals lacking the characteristic of interest. And what we hope for in our control group is all these hidden variables. If ideally, all these hidden variables are going to be the same as they are for the treatment group. So we would say a good control group will control for all possible hidden variables meaning that these third variables will be the same, will be balanced the same as they are in the treatment group. So just, right, just look at the table again and think about it. If we can have, this is our control, treatment. If we can have all these other variables at the same level between on the two sides, then we don't have to worry about them driving a correlation, right? They can't. Because if we got just as many risky drivers here as here, then that can't explain why a red car would have an higher accident rate, and so on. There are two ways of controlling for a variable. And these won't make sense to you initially, but hopefully they will in a minute. First is you simply eliminate it as a variable in the comparison. And the second is you spread the variation or spread the variable equally or evenly between treatment and control group. So those might sound to be the same, but the thing we'll illustrate next is elimination. So we'll start with 1. And I think this will be pretty intuitive. So let's eliminate car type as a variable in the correlation. So let me give you 4 choices here, or 4 options. So we'll have 4 categories, I guess. 4 red cars that are sports cars, and I apologize for defaming the name of sports cars. We're going to consider them to be dangerous cars, whether they are or not, doesn't matter. But we'll have red safe cars, non-red sports car, and non-red safe car. So we want to compare 2 of these 4 categories that eliminate a car type or controls for. So which comparison controls for car type? And we have 6 choices: A and B, A and C, A and D, B and C, B and D, and C and D. 6 choices. So how many, we'll do this by a show of hands, right? You got this written down yet? How many are going to vote that a comparison of A and B controls for car type? A and C? A and D? Got a bunch of lead on our hands, can't lift them up. Let's try this again. So look at this, think it through, right? We want to a comparison between red and non-red that controls for car type. So, how many are going to vote for A and B? Why not? Or why? What? 2 different kinds of cars. So it doesn't control for type of car. Does it allow you to compare red with non-red? No. So it's got 2 problems, right? It's all red cars, so if you compare them, you can't look at the effect of red, but that doesn't control for car type. How about A and C? Are we going to vote for that? So a few brave hands going up. Okay, so so we can compare red with non-red, and it's the same type of car, which means we have eliminated car type as a variable. So whatever the accident rate is due to being a sports car if there's an effective color, we should see it. So that's one. How about A and D? So does it allow us to look, does it have two different car colors? Yes. Does it have the same car type? No. So it's like part way there. How about B and C? Okay, and that's the same reason there. How about B and D? So what in B and D, we've got what? Both the same type of car. Safe car. So car type is controlled, and we got red versus non-red. So there are two ways with these four categories that we can do a comparison between red and non-red, and we've controlled for car type, because car type is the same in the comparison. So we could do the same thing for other variables we think of, right? We could go back to our list. We did safe, non-safe. We could do it for drivers, right? We could take drivers that have, say, the same record, same age, etc., and try and control for driver type that way. We could do it for old versus young cars by having cars of the same age. So we can just make a comment, can do for other third variables. Now a question, can we be sure using this approach that no third variable explains the correlation? Yeah, I murdered that up. All right, so if we kept doing this, could we satisfy ourselves that we're done, that we actually ruled out all possible third variables? How many say yes? How many say no? Why not? Yeah, you might not think of them, right? You got to be able to think of the third variable, and even if you can think of it, you might not get the data. But even if you could, even if you could get all possible data, you have to be able to think of it. And if you may not know what it is. So the answer is no. We may not be aware of the correct third variable. Second approach is you do not eliminate it as a variable, but you spread it or balance it evenly between the control and treatment groups. So you would have red, not red, X% risky, Y% safe drivers. You'd again have X%, Y% over here. You might have A% safe, B% not safe. Cars, again, you'd have A%, B%, and you keep going down like that. Then the control group will be the same as the treatment group for third variables. Yep. So we'll be going into that, but that's, yeah, so I haven't told you how to do this. We will be talking about this in the context of something called experiment. And I want to put one thing to you that I don't know whether it'll help understand correlations or not. We're going to call this an aside on how you get a correlation. So I'm going to give you a table that is the accidents per 1,000 cars per year. Red, not red. And we'll do sports and safe. And I'm picking on sports just because it's easier to write than not safe. So this will be the accident rate. And suppose the numbers are this. So first of all, what does that tell you about car color? So is there a difference between having a red car and not red car? Okay. And so what does the table say? Yeah. So well, you said not red cars have it. Yeah. So being in a red car, whatever type of car it is, being in a red car would mean you have half the accident rate. That's what the table would say. The question is, if this table was true, how can you possibly get a correlation in which red cars have the higher accident rate? Without adding any variable at all. If you had this table, is it possible to get a correlation in which red cars have a higher accident rate? How many think it is possible? How many think it's not possible? Well, we had a turnout of 2 for that election. This is true, right? I was giving this lecture for 5 or 10 years, and one year it occurred to me, wow, you know, I'd never even thought of putting this table up there. But, so ponder this a minute. Actually, the sooner you come up with the right answer, the sooner you're out of here, because it's the last thing I want to talk about.
Wouldn't you just need to figure out the percentage of red versus the percentage of everything else? Like all the rest of the time?
Well, you're on the right track, but so would it matter whether there were whether red was 10 times as common as not red, or they were equal, or any of the other things. You're halfway there.
Like, when you compare like red to white and then red to like silver and red to black,
Well, we're pretending all other colors are the same. I mean, have the same accident rates.